welcome to part 16, I believe, of the Formatables Refactor. So in part 15 we managed to get rid of a number of entities, which was quite pleasing. And we are hurtling towards the end of this sprint as well. Let's have a quick look at our clock. We haven't actually started clocking either. So probably started around 30 past, I guess. 73 roughly hours, so we got another 7 hours or so to go to the end of the sprint. We probably won't be able to finish all of Formatables Refactor sadly in this sprint, but excuse me, hopefully we get most of it done. It was certainly a very ambitious exercise, really. What we're going to do is tackle one of these at a time. As you can see, there's a pairing of the data type plus the accompanying transform. I'm hoping that all of these are quite trivial. I'm just going to have to pray. So let's start with the streaming properties. Now, we're not going to really do the complete modeling exercise that should be done with this. Really what we should be doing is we should be trying to figure out the rightful place for all these things, and we should try to understand if it's a technical space related thing where it should fit and so on. But in reality we're just going to do the quick exercise, and then once everything is in the right place in the model, then we worry about it. So for example, we can see the streaming properties are mapped by logical ID, and I think the crux of this exercise is that we need to access a whole load of streaming properties, not necessarily knowing where they are. So let's imagine, for example, a concrete case. So we need to know if something requires quoting, or the string conversion method and so on, right? So what we must do is we must go through the configuration of every single logical model element, and then we determine whether these things are populated, and then we create one of these entries here, and then we use that to do the right thing. Now, if we think about this for a second, the ideal scenario should really be where we have these properties next to where we need to use them, right? So for instance, we could say if you have a property of type X that requires string quoting and so on, you get to know that that property will force you to use the quoting. So in fact, let's just have a quick look how this thing is used. See, this is the problem. If we start investigating too much, then the whole exercise becomes quite difficult. We almost want to strike a balance here between refactoring and just moving things across, lift and shift, really, as we say. But I will have a quick look. So we have the assistant, we have the helper expander, which is also making use of it. Streaming properties itself, formatable model, the helper configuration, streaming properties, and the streaming expander, which is our target, then the model, configuration IO. Okay, that's actually quite self-contained. It's not like all over the place in the templates, which is good. So that being the case, let's just see what the assistant is doing then. So what the assistant is doing is basically saying, well, you call streaming for type, I guess, and then the assistant will give you the right incantation for streaming. And how do you obtain streaming for type? Well, you give me a name, interestingly an ID as well, and I shall give you the incantation. So I guess what we really want to know is how is streaming for type being used, and that should really be in the templates. So one template here. Yeah, so basically the different templates we are effectively asking for different streaming properties. So the right fix for this probably will be to have the right incantation for streaming directly in the logical model against each type. So for example, let's have a look at this guy here. This is generated code, so it looks a bit messy, but see, as you can see here, we go through the attributes, and then for each attribute we ask for streaming properties. So really, the right fix for this, now we just have to try to contain ourselves a little bit, because clearly what we should really be doing is we should be putting this against the attribute already, all of it nicely massaged already with the right output, and then all we should be asking for here is, please tell me what my streaming is, instead of going through all of this confusion. So we just need to make sure we're not going to make this too complicated by doing that. If we just go back to our assistant, and then of course we also want to make sure we're not going to be computing this more than needed times. So we could easily have a transform that goes through the whole model, computes the streaming for type, and then goes through all. I mean, we just have to make sure that we always look for the local attributes, because of course there are multiple containers with attributes in logical model. So if I look at object, for example, it will have a context, template, local attributes. So we are with inherited attributes and so on. So just have to be careful here, because if we populate this after we've expanded the attributes, we will have inconsistent information. But you see, we already started the process slightly here with things like member variable name, getter setter name. Of course, this should really truly be language specific, I should say. So we should really have a member variable name for technical space. But that doesn't affect the current thing that we're trying to do. So we just need to understand what the streaming expander is doing. Let's have a look at that then. So the streaming expander is going to create a set of features as you'd expect, and it's going to read the features, and then it's going to create the associated streaming properties. And all we're going to do is go across all the model types and do that. And then we slot that into the container against that ID. So you can see here, this is a classic case where, on hindsight, things become a lot clearer, really. You can see here what we're trying to do, really. We go up front, we go through the whole model, we obtain the properties for streaming for that specific set of types, and then we put in a container, and then we do a lookup for that container. But with hindsight, we can now see quite clearly that actually the final use case for this is merely to ask for the streaming for type. Now all we need to do is to make sure that all of these instantiations of streaming for type are to do with attributes, which presumably will be, but let's just double check. Interestingly enough, we have containee here. That I think is just a name. So that is actually just a logical name, I believe. Yeah, so we basically only have a logical name here, and then we go and do a lookup. Okay, so this use case won't work if we move it to the attributes. And I suspect, well, let's continue searching really. Again, same thing. So basically, we can fix the problem for the types, but then we won't fix it for the helpers because the helpers are relying on another kind of reference, and that reference is actually name only. A bit of a shame really, but yeah, as you can see, for the proper use cases, this would have resolved the problem. But the helpers are not proper use cases because we designed the helpers in a kind of a weird, haphazard sort of way, and they will be removed in the future when we got PDMs, but don't have them just yet. So we can't actually just do that one fix, which would have been the right fix. However, nothing stops us from supporting both. The only slight problem, of course, is that the system doesn't have awareness of the logical model. So if we put this in the logical model, then we still need to unpack the container from the logical model to supply it to the assistant. So let's think about this. Would that be a good idea? Clearly this should be a logical transform because as you can see here there is absolutely no need to go over to the physical dimension. Just reading some properties, slotting them in. The only question is where those properties are going to live. I'm actually just going to take the easy way out really. I'm going to actually just map this to the simplest possible absolutely trivialist possible approach, which is more or less a copy and paste job. What we're going to do is we're going to say in this logical model, shall be a new container here. So you can see the logical model was fairly organized. We've got the groups of meta modeling elements, which are all organized into these repositories, depending on their types. And then we have other things such as technical spaces and root module and leaves and so on that are containers that live here. And so what we're going to do is follow on that pattern. If you remember, we can't really copy and paste properly in this dia version. Doesn't take the namespace into account. So what we're going to do is we're just going to copy and paste by hand. Now, as I explained, the right thing for this would really have been to put this as a property of the attribute. And to be fair, we may just, in the end, do that. We may just, after we've done a pass that populates this container, we can simply, that's just simply a boolean, so there's no point to copying and pasting. So after we've done this container, I think, I forgot about the color, F7E. So F7E, that's the guy. Right, so there you are. The model will contain streaming properties. So you can see this is very straightforward, and then we will just basically say, well, what exactly are these? You can see here very simply just a logical ID. So this is the sort of the quick way of doing this, which is kind of what we want really. We want to just be able to get this done quickly. And then of course we're going to have an associated transform. I guess we could call this streaming properties transform. And our logical model transforms are already fairly complicated. Now, this could probably be a pre-assembly thing, really. We don't particularly care where, to be fair. So I reckon doesn't really matter. This sounds fine. Right, and as usual. Right, so most of these guys here are working in terms of model sets, interestingly enough. Few of them are working in terms of models. Let's just double check that. So if I take, say, dynamic stereotypes transform, whatever that is that really working in terms of model sets? Yeah, it is. And if I take labeling transform, that is just a plain model. Okay, fine. So we have a mix and match between models and model sets, but that's fine. We'll just go with that. Continue the pattern. So here we need a context and a model. And we will need some color. E5E, so to memorize these colors at some point. And we just need to hook that into the pre-assembly chain. We're going for the pre-assembly chain because, interesting. Okay, going for the pre-assembly chain because you should always try to transform things the earliest it's possible. So if there's absolutely no dependencies, that's just a trivial thing. You can do it really, really early. Just do it. And that's what we're doing with this guy. Not entirely obvious the best place to put it, but seems like we're making a little ladder here. Right, there we are. So very simple. Streaming properties transform, and then we've added string properties there. And we could, while we're here, add them to the attribute. Let's think about this. So once we compute, we need to figure out all attributes that reference. Okay, that's interesting. So, so we must have like an attribute transform. Clearly, we must resolve the attribute. In fact, that's interesting because it's not entirely clear to me how we know what the streaming properties are for a given attribute, because oh, presumably they're only important if it's for a type. Yeah. It doesn't really matter if you've got a nested type, really. It just matters is the top level type. Finish my coffee here. So presumably all we need to do then is to try to make sure that let's just have a look at attribute related transforms here. If there is like let's have a look. Anything to do with attributes anywhere? This is where having a text representation of this is going to make life so much easier. So just get my shirt off. A bit warm here. So what are we saying then? We are saying that somewhere we must be doing some attribute related processing. We definitely have things to do with generalization and so on, but there must be already an existing attributes transform. Let's just have a quick look at the file system, I think. So if I just look for attributes, here we are, attributes transform. Now, why is the attributes transform not visible? There's so many of them. Oh, there is. So the attributes transform is quite late in the chain. What does it do, I wonder? Wonder if it does the expansion of the attributes. Yeah. So it takes into account object templates and then performs some copying parent related copying. So I wonder, and we already have other things here like fluency and immutability. Yeah, this could be a good place to do this. I wonder if... So let's just look at this more carefully then. So first we expand the object templates, then we expand the objects, whatever that means. We probably should not call expand, but transform or something like that, but we fix that in a minute. So what do we do for object templates? We we're basically trying to populate from the local attributes, populate sort of things like all attributes and so on. So I guess the first job would be to say populate all of the local attributes. Yeah, so I think we can probably get away with this. What we're going to do is we're going to add the streaming properties directly to the attribute. It's a bit coarse modeling, but I think you get what I'm trying to do here. And then, I mean, we don't have any commentary or anything like that for now, but that's fine. And then the idea will be, and in fact this probably are boost optional streaming properties, because not everyone's going to have them. And then what we'll do is we'll make sure that the streaming properties in the attributes get in the local attributes get populated, and then by magic it should propagate across. So our transform will just do both, and I think this is it. Of course, we have the same problem as before. Conversion method should probably be technical space specific, and I think this will come to a head once you try to merge C#, because I bet you there will be something similar. Not that I can see, but okay, maybe it's just because we haven't got as far as C# model. So there you go. I think that should do us. Let's go and try to generate that. If it works, it does. So let's convert the logical model. Let's see what damage we've done. So that doesn't look too bad. So let's oh, and that was a mistake. Right, so what we really want to do is to see if the tests are passing. Okay, so this generates all the types related to streaming properties that we need for this exercise. So with a bit of luck now, we just need to go and implement this transform. That will be largely a copy of this guy, not quite, but very similar. And then we just need to update the assistant to take into account, well, we'll have two scenarios really. In one case we will have, oh actually, to be honest, one thing we did not do, we should probably have done, is we should have looked into what the assistant is doing. I wonder if it would make more sense to say just store the streaming for type actually. Because what you can see here, in most cases what we're doing then, we're just basically saying for a given type we'd have all the streaming properties, Yeah, sorry, actually, after all that, I think we might have to revert this a little bit. So, we are storing, let me just explain what I mean by this, right? So, what we're doing at the moment is we're storing, and this is exactly why we ended up with the assistant. So, instead of looking at the end result, what is that we need at the very end? And at the very end, we're going to end up with just a string, right? And that string will just be mapped to a given type. So, it makes no sense to just have half of the work done, only to then do a little bit more work when we get close to the templates. We should just get the transforms to all the hard work to the end goal. So really what we want is a streaming for type. Now we need streaming properties, of course, because we need to read that from the configuration, but it does not seem obvious to me that we need to store the streaming properties at all. Really what we want to store is a streaming for type. Of course this guy here is then using some formatting, but that's fine, we've done that in other places. And so that, all of that being the case, we could create a map. Oh, actually, since all the tests are passing, we'll just commit this anyway. But logical generate streaming properties related types. But that's fine. We tend to not to do uncommit things unless we have to. So I mean, we did that work, so that doesn't really matter. However, what do we really want to do? Streaming for type. The slight problem, of course, is that you still need a lookup by logical ID to streaming for type. So let's just imagine that the transform does all the hard work, reads all the metadata, and then for each type it read in the entire model or group of models will generate the streaming for type. Now the key thing to remember is that we have two stages here. We are prior to the assembly, so prior to merging. So this will be done per model. Each model will have their own streaming for types. Then we start merging, but that's not a big thing. We could just merge the collection, and then the complete collection will be available in the model. So that being the case, we probably don't need to store the streaming properties. And in fact, we might even go as far as saying the streaming properties are going to come back on the back of the generated code for the feature. As you can see here, we have them here. So we read that for the type, we will do all the processing, we'll slot it into a container, which is just a string, and then quite nicely we can say the same thing for the attribute. So where we are doing all that complication of streaming properties, we could just say streaming for type. The attribute has it, the container has it. Okay, right, this seems like a better approach. So actually, this is not really a very nice name, but you know what I mean. Let's just say streaming for type. I know this is really not ideal, but this kind of type of modeling is done in several parses. So so we'll call this streaming for type as well, and now here we'll just say actually this is just a string. Okay, very simple, very easy. And then what we'll do is, for good measure, we will look for the features, and then we will just create a variability a feature bundle here. This is really the crux of it. So streaming, okay, you can call it just streaming. Let's see if there's anything that could clash. No. Let's get an idea of the color scheme. BAD, nice hex string, And now the magic will come from these guys here. So we'll copy that. That's clearly not the case, so I think we can just default it to true. That's fine. And then let's look at what we call these guys here, for example. MASD.physical. Well, that's probably not a good example. Labeling, perhaps? MASD.label. Well, actually, we haven't got much of an option. We're just going to have to take whatever it is that we got them on, otherwise the models will break. So that's fine. Take the streaming property here. And add it here. So we already know it's going to be dot streaming. Bit of noise coming from my phone. Just put this on less noise. Always difficult to concentrate when you have lots of messages coming through. So, in fact, let me just see if this message is important or not. Not particularly. Right, so what we're doing is to take these guys one by one, very carefully, rather carefully. Okay, that looks good. Okay, so rinse and repeat. Now, I think we'll be able to delete these guys once we're done with this, but let's just do them all. This is going to be identical. All text, I believe. Oh, there we are, Boolean. Never assume anything. Maybe if I'd read the name of the type, I would have guessed that. So you can see why this is such a slow process, really. Because you have to think, you can't just copy and paste without thinking. But that's good, because that's the whole point of the exercise, really. We're not just moving things across, we're trying to improve the conceptual model. So, okay, so Boolean, we got Boolean there already, so you can copy from this guy, be a little bit quicker. Right, so what you can see here now is that this guy is going to generate a whole load of machinery to read the feature. We don't have to do this by hand anymore. It shortens space, so I have to move things around a little bit. Not brilliant, but you know what I mean. So we now have got all these guys here. He's streaming, and this I think will now generate the relations correctly. So all we need to now do is to say, don't generate these guys here. Generate the other guys, and that's good. And then if I just go and generate this, hopefully we don't expect anything to break. If everything goes according to plan, it's the usual conversion. So you can see we changed what we've done. I mean, this is fine. This is how modeling works. We do certain things, and then not quite where we want, then try again. Until it makes sense. Let's see how long we've been in. So 34 minutes already, not particularly fast. going. Always Windows is always the slowest. Right, so then you can see how nicely this is moving, although not as fast as we would like, but this would now allow us to remove all of these guys here. Types will be modeled a little bit better, and making use of standard infrastructure instead of building our own. So that is exactly the process we're looking for. Steaming properties from then consolidates a number of operations we got here. It's going to consolidate the reading of the metadata, the processing, and then finally just the streaming for type. It will have exactly all that madness that we got in the assistant. Stuff like this. And that's a much better way of doing it. And then let's just have a look at why we have so many streaming for types. Well, to be honest, the key thing about these streaming for types is at some point we end up with a logical name. And so, excuse me. Once we have a logical name, we can query our container, and we're done. Got a problem. Ah, this is interesting. Did not expect any problems. Oh, of course, what we forgot to do is forgot to do the same job for C++. Choice of having two different representations. Okay, so let's try again. So refactor types for streaming properties. Okay, as you saw, let's just double check that the code generator is still functioning. And as you can see, the code generator is still working just fine, even though we moved all those features to a different model. So that's all good. Now then, we start the actual work. The actual work will be something like streaming properties transform, and it will be based on any of these. Not the assistant, clearly. Something like the labeling transform. Be easy enough to copy from. And probably needs a bit of commentary there as well, so let's have a look at what the loading transform is doing. So right, this is just reading labels, isn't it? So let's say something like populates all labels. Populates all labels, I don't know, something like that. It's probably gonna reads streaming properties from configuration and generates the correct streaming incantation for each type. Incantation probably. Sometimes Portuguese and English. Incantation. Similar words, but not quite the same between Portuguese and English. Right, so there you go. Something like this. then what we want to do is we want something like, well, probably need an exemption, need a logger, need a tracer. We'll need some model IO. We'll do. I should think we will need some kind of logging. And something like this. Not sure if labeling is spelled correctly, but we'll have to check that some other time. Well, let's just check it now. We'll define labeling. I think it's labeling with just one N. No, double N. Double L. Correct. Right, so our apply is rather identical to this guy. We just need few updates here. And we don't really need that stuff. Righty. And of course transform as different role. Oh. Okay. Alright, so two steps here then. The first thing is going to be to hook this in to the main pre-assembly, if I'm not wrong, pre-assembly chain. And after that we need to remember that the merger needs to merge the maps. We'll just do it after the labeling, to be honest. Doesn't really matter where. Yeah, just stick it here. Okay, so this transform is not going to do anything, but ideally not break anything either. I couldn't help but notice that we do things here very statically. I mean, if I was working on C# or Java, by now there would have been some kind of transform interface, and that transform interface would be managed dynamically, and there'll be a way to manage the graph of dependencies rather than doing it manually and so on. But I actually, quite on purpose, did all of this by hand in Dogen because I just wanted to see if we did it like very simple. I just wanted to see the problems that we'd get. So in other words, don't spend too much time on creating an infrastructure for managing transforms and dependencies and transforms and so on. Just see how far you can get with the simplest possible approach. And to be fair, up to now, we haven't had many problems. So I'm not sure if we're going to end up actually upgrading all of this to some very more complex framework of transforms. So implement skeleton of string properties transform, and then we could say what do you call commentary labeling the transform. Be nice if it remembered that we use the word transform all the time. And hook in the streaming transform to pre-assembly chain. So hook string transform into hook the string transform into the pre-assembly chain. Right, so those are the very simple operations that we needed to do there. Quite straightforward. So now we'll start by looking at what the streaming expander is doing. Now see, all this stuff is before we had code generation for features, so we were doing all this by hand. We don't need to worry about any of that now. We literally just need to loop through the model elements. Now let's look for a transform that's already reading something, such as decoration might be doing that. Let's see if there's a variability. Not really. Let's just try a few of these randomly. This one is good. So let's look for the feature selector. Ah, not being used. Interesting. So we are using, maybe it's historical, but okay, this is good. So a bit of noise downstairs, see what's going on. Okay, everything's fine. So what we're doing, we're saying, oh yeah, the streaming properties transform. Right, so what we need to do then is we need to say something similar to what we've done here. The first thing is go into the logical model. I wonder if I just type logical. No. Ah, it does. Very good. Dogen types feature. And then there should be a streaming .hpp, all good. And then we just need to do something very similar to what we've done here, which is read. So I guess what we're going to end up doing is we're going to end up creating a container which will be rather similar. Or do we actually? I mean, it seems a bit wasteful to create a whole container when we can do everything in one step. Why bother to create a container, really? So perhaps what we need instead is, we'll call it populate enumeration. Let's see how it works around here. So we simply obtain a feature group. In our case, it's going to be features streaming, and then we need a feature model. Feature model would be available from the context. As you can see here. So at that point, we are now ready to apply the feature group. So we need some kind of loop. So let's say something like, of course we are not able to just directly loop through. Oh, we probably are actually, because the only types that are affected by these are going to be objects, I believe. So let's just have a quick look at what this streaming expander is doing. I believe we must be looking for. We don't really care at the moment. So it's possible this applies to other types actually. So you have to be very careful here. We don't really know which types are going to have this. So let's not make any assumptions then. So what we need to do instead then is we need a traversal visitor. So let's look at RG. See what RG says. We need something like this. And we can just take any of these transforms, such as well, say this guy here. Well, actually, this is probably the most complicated traversal. Let's do a slightly more trivial one. Right, there we are. So all we need is to supply a class that's able to process, and to be fair, we don't even care about the types because all elements have configuration, so we could literally just say give me any element, so quite possibly the simplest transversal you can imagine. and then it will generate the map for us. So this is looking good. Something as simple as this. Let's call this generator, whatever, doesn't really matter whatever name we want to call it. And probably could say variability entities configuration. Right, and then actually I just want, well, believe it or not, but the elements. Now, not clear. In fact, it could be a const element as well. Now, we're not clear why the entities element is not being found. To be fair, I want that to be stats and values. Interesting. I wonder if the problem is that we don't have element. I wonder if the name of it is not elements, perhaps. It is elements. Not quite sure. Okay, that's very strange. Okay, what's this? Let's try again. Logical entities elements. I think we're just getting rid of it. This is what I mean about concentration and recording. It's just difficult to concentrate. Very strange why, really, but well, that seems to have improved things slightly. Now, since we're somewhere in the logical model, we would have thought this should work as well. And our objective will be to construct something like, well, I suspect we just need ID to string, really. If our work was done correctly. Something like this. And of course we could do a using so that we don't waste so many characters. Save the characters and all that. Okay, cool. Hopefully you're getting the gist of what we are trying to achieve here now. So this is just our results. Don't bother naming. Right, now then. So our lovely processor here. And if I go up to RG, we should now have the transversal. This guy. And right, so that has to be somewhere around here. There we are, bingo. So then, what we're going to do is something really similar to what this guy does here. So there's no for loop. What we're going to do is we're going to use one of these guys here. We call it whatever you want. Doesn't really matter. Be nice to create these types without name actually. But this objective is to just gather all the stuff. And then we pass the G to here. Right, so you see what we're doing here, right? We are But one thing we probably need to do as well while we're there is to supply the feature group really. So we'll have a public constructor, ideally explicit. We'll take a const feature streaming. Let's see what we have here. Feature group perhaps. And then we will keep track of this. Around here. So now then, once we create the gatherer, we supply the feature group, and away we go. Righty, so let's implement these guys. Quite straightforward, hopefully. So the feature group is simply something like this. I mean, we could inline this, but sometimes I get lazy and one way or the other. The process method is going to be a bit more interesting, so we'll do that in a second. The operator, well, to be honest, I don't even know why I bothered to create a process and an operator, because this guy is just going to delegate. And his job is just going to be something like e.configuration, truth be told. Okay, right, so I'm getting a bit upset about methods that are so trivial, requiring definitions, so I'm going to actually change my mind. There's a lot of overhead for no reason. Not sure why it doesn't. Oh, there you go. And then process, of course, is going to be the more complicated one. And results is also quite a trivial method. So what we're going to do with results is simply return results. Okay. And this is probably okay. Right, as you can see here, we are well on our way. Now we can just simply say, please take a feature selector. No, actually we're not going to use the feature selector because we know there's no need for that. So you can just go to whatever we were before and look at how enumerations did it. So we created all this infrastructure that automates the process. So streaming. As you can see here, what we're doing then is the static configuration will come from the feature group. Could probably do something like using this guy. Don't think we're going to be using because it's a class member. So well, now I don't actually need the full of E. Though to be fair, well, doesn't really matter, does it really? Right, at this point in time we now have the static configuration. That's all we care about, and then we can go back to the streaming expander. Now it's not necessarily the case that these things will exist, so you still need to do something like this. They're optional, presumably. Let's have a look at how we created them. I mean, there must be, but just to double check. Need to be cool air coming in. Double check these things are optional. Oh, they are not optional actually. Oh, they're not optional, but they do have default values, so that's fine. So we can just get the whole thing. Yeah, it's a bit strange that we did. We're exchanging the semantics slightly because here, yeah, well, but then that's because purely because we have optional properties. We don't really have to worry about any of that, right? So all we need to say is something like this. What does the assistant do with these things? Right, so first is we need some utility. Okay. Then type. Oh, we should just bookmark this guy. Now we have the utility. We'll need some kind of a stream as well. And not quite this guy. Well, I think it's just this guy, right? And so it will be something like this. We look at the config. If so, we do that. Then we look at the config again. Right. We here are trying to dump the string properties for type. We can't really do that because there is no I/O available, but what we can do is we can dump them one at a time. So this will probably do the trick. Something like this. And then finally the string requires quoting. Right, so you can see what we're doing here. We are literally just expanding all of that processing, collapsing all of it into just the one method. And this just does the dump of all the values for that particular type. We read them from the configuration. We will dump them here so we know what they are. Then we start to process. So this guy is just an output stream. It just takes one of these guys. Now, what do? Interesting enough, we have S. What is S? Ah, this could all be in vain because we don't really have this S. Oh, presumably S is going to be so what is going on here then? as is supplied to us. Okay, we probably didn't analyze this carefully enough. What was S? So let's look again streaming for type, but this time let's go for everything in projects. And the assistant is asking for a S. Right, so sadly, the streaming for type sadly requires two different parameters. The logical name, which we could get away with, because that's going to be the type that we're looking for anyway. But there's this parameter which is a bit more complicated, because sometimes it's a pointer, sometimes it's not a pointer. And there is no easy way of knowing up front whether it's going to be a pointer or not a pointer. So this is quite annoying. This is exactly the kind of problems we face all the time. It just, things look so simple, and then suddenly you for such a tiny little thing you end up having to change the whole modeling. So it may just be that we have to revert back to the previous model. It seems that it is not possible to generate the streaming prior to knowing what type of attribute we have. So the helper is the only one that knows the type. I mean, the attribute itself would know, but of course we have the problem that the helpers are not always, well, it's not clear how the helpers are doing this really. You can imagine the helpers are obtaining these things here from God knows where, so it's not possible for us to do that. So close to simplifying this quite a lot, but it seems like we can't. I don't think. I mean, it is possible that we could now go into, and you can see also there's other cases where this S is not quite that simple. Right, so this will not work. We could somehow, one of the problems we have at the moment is that the code generation is not, a code that we generate can't allow us to, it's not a merging code generator, so I can't just create a simple function. It would be very trivial to get a function that took an S and just replace something in the string. But we can't do that. However, what we could do is we could create sort of a mustache template, a mini mustache template, where this bit here will be templatized, and then you would just call the assistant will instantiate the template, and then obtain the final value. I think that's not too bad. So let's have a quick look at how templates look like at present. So I could just literally just have a bracket argument. So all the processing, all the hardcore processing is done. So let's just go with that first and see what happens. So so let's call this const string argument, and we'll call that argument. And so wherever we have S, we will now take argument. And actually, to be honest, I wonder if it gets even better, because we are now determining what the argument is. I mean, you can see the fresh levels hackery that we got here. We are now determining whether we are being referenced or not, and then based on that we are then doing other stuff. Great deal hackery. But so this is far too complicated to simplify. The right thing to do is really, well, we know exactly what the final destination of this is going to be. We're not going to have helpers because the helpers will be replaced by PDMs. Once we don't have any helpers, we can put this property into the attribute. The attribute knows whether you're a pointer or not. It knows all this sort of stuff. It knows what V is and so on. And because of that, it can do all the right calculations. So so we could quite easily implement this transform properly. So what we're going to do instead is just create the story here. So refactor streaming properties processing. So we could say something like at present we copied across the logic from text.cpp where the streaming properties are stored as a class and the final processing happens in assistant. However, when we get rid of helpers, we could do all the processing in attributes. In all the processing in a transform in the streaming processing transform and store it in attributes. Okay, just some kind of note that would be enough for us to remember what we're talking about. Right, so what we need to do now is, quite sadly, is we need to now do something non-trivial, which is we need to take, what is all this about? We need to revert back to the model we had with the streaming properties in yeah, this version here, I think. So what we do in these kind of cases is we probably, well, we have the features already, I think. Well, to be honest, you know what, I normally would actually try to do some git reverts and all that sort of clever stuff, but to be honest, I reckon it's just quicker and less complicated to go back to copy and pasting. So what we're going to do is we're going to abandon altogether the notion of trying to do all the processing here. We will return to an approach where there are streaming properties, and you just call the streaming properties, and this guy here stores the streaming properties. And what we'll also do is, for good measure, we will also abandon the processing at the attribute level, because this is just not going to be correct anyway. We already know what the right thing is, and there's no point in doing half of the job now. I don't think, because it's going to make the code very confusing. If you look at this code now, you're going to be like, oh, what is this supposed to be doing? So what we'll do instead is just get us back to where we were. So these things, sadly, this is part of the job really, is you try to do the simplest thing, that doesn't work, then you go for the second simplest thing and go around in a few circles until suddenly it all starts to make a bit more sense, I think. Right, so as you can see here, we quite quickly copy this across. You can easily say these guys are related. Right, there we are. So streaming properties contain the logical ID, the streaming properties themselves, and pretty much nothing else needs to change because we still need the features. So we're going to read them, we're going to populate them, and away we go. So let's just try to generate this guy and do a quick conversion. And indentation. And then I know we're going backwards and forwards, so it's probably hard to follow all the stuff that we're doing here, but you just have to bear with me a little bit. Right, so if we go back to this guy here, then now we know for sure we don't really need all of that. We could probably, well, to be fair, we probably need the features. I should think. And we could just leave it at that. See how close we are to compiling. And this is kind of like this is the ask really, this is the task. Why it's so difficult is because it's only when you have a good vision of the end-to-end exercise that you can start to see. And so this is another place where I think it's good for us to stop and think a little bit. So we've done Dogen in sort of layers. First, remember that Dogen is an empirical project, it's not a formal project. So we're not trying to create here formal rules to work for all cases. We're just trying to look for a very small subset of cases that we can prove with empirical means that it works. And so the reason why, excuse me, we just tend to implement something, anything, get it going and move over to the next stage, is because we then use those implementations as a way to validate what we're trying to do. So for instance, if we had not implemented all the transforms by hand, if we had not put all this stuff here, we would not have known about this variation that exists on the way we're computing the streaming for type. So yes, it may be a hack, but it just gives us some empirical evidence of the better way to model things. And so I think this is an important way of this, how things work in this approach. It's also very difficult to have all these things in your head, I find anyway. So it's a good thing that we have lots of little concrete examples of all these very abstract concepts, because otherwise I think we'd lose the plot by now. Okay, compilation is going. But we'll just wait for the compilation to finish to start fixing all of these types here. Well, to be honest, we don't have to. Let's just get cracking, I think. So we will have a map, and the map will contain. Yeah. So, oh, actually, looks like we finished, but oh. Interesting, we managed to break the world. Let's rewind this for a second. So, ensure not empty. So let's look at what the selector is doing. Was peculiar. I didn't think this was going to be that bad. Well, I suspect it's us here. So I think we have no option but to comment out a whole lot of stuff. Not quite sure how you're supposed to do the C# comments in Emacs at the moment. Sorry, the C++ comments. Always end up, can't select and then comment, doesn't seem to work. So always end up having to redo things. Right, so then, in fact, I don't know why we didn't just comment out the whole lot, but oh, what happened there? Basically, there's nothing easy. That's the conclusion of this work. Every time you do something absolutely trivial, some big problem always occurs. Just very pleased this is not actually a sort of professional job, right? Because you can imagine you have your team leader on top of you all the time trying to get some results. And this, in a way, this is a really good conclusion that I think goes in line with what I'm trying to say in my thesis. This meta-programming is all fine and dandy as a sort of a exercise for fun. It's actually quite a hard thing to do professionally because Um, it is actually quite complicated. There's lots of problems that occur, and you just have to deal with them. And we don't have time to deal with this sort of stuff on a day-to-day basis. It's very difficult to explain to your boss why you're delayed when you're dealing with this sort of stuff. Reinstate streaming properties. Okay, we know what that means. Logical, remove, unused, include, enumeration, transform. Also know what that does, so it's all good. Now let's try to understand why it is that we're breaking the whole world with whatever it is that we're doing here. Not very obvious if I'm honest. Looks all quite innocent to me. So we were trying to create a static configuration, and I wonder, so what is the static configuration going to be doing then? I think static configuration, so all this is doing at the moment is just building the static configurations. Nothing particularly special is happening here. I think what's happening is that because these things are not optional, but they're not available in all configurations, that's why it's breaking, I think. Ensure not empty. Actually, I'm going to be a bit lazy here. Let's see how far our debug build is. It's just easier to just quickly see what the debugger says, but so how are we doing for time? An hour and 22 already. It's actually longer than we expected, just for the very first set of features. Thought this would be quick. We have tried a couple of approaches already. Right, while that's doing its thing, let's just look at the code. So we're making the static configuration. And yeah, that's actually looking all quite good. This all looks quite good. I'm not even sure why this is failing. It's just some configuration thingamajig. We did something wrong in the configuration. I wouldn't expect this to fail, especially not with some kind of weird error. So we are looping through the model, every single element in the model, and then we're trying to read the variability, the configuration. Then since we read the variability, what we'll do is we're going to create a streaming configuration. Then we're going to read the properties from here and populate it over there. And if I go to the expander now this is all going to make a bit more sense, because we are literally just going to copy and paste the logic from here. So we just need to copy and paste, and then what we'll do is we will probably use the same logic. Now this is an interesting thing here. So we don't really want to create lots and lots of entries for no reason, because I think in the end the assistant will probably expect some not to exist, as you can see here. So we should really, let's think about this, we should really detect whether we had a problem or not. Okay, cool. Actually things are worse now. Oh, I wonder if we have cases where the configuration, oh yes, Where are we in the pipeline? Could it be that we're dereferencing non-existing configurations? I think we are. Right, let's just go up to the GDB area and let's just run these guys here. This is really not ideal. I think what we've done, this highlights the problems with C++, I guess. We assumed that the pointer was actually pointing, but I suspect configurations are generated somewhere further down the line. Fantastic. We are probably too early in the pre-assembly chain. There is going to be some kind of variability transform, and I bet you that if we look at the pre-assembly, whilst that's doing right, so unfortunately we can't use the eyebrows shortcuts because CDB doesn't like them, but it's fine. So if we just quickly switch to compilation perhaps, and in compilation let's just obtain a few variables that we need, and then if we just, while we wait, step these just get all these set up. And then let's just move. Now I'm pretty sure all that's going to happen is we're going to break what's interesting. Okay, I'm pretty sure this is all very confusing, but what's happening here is actually not that complicated. Let's just jump all the way to frame 9, even 10, and then let's just print, no, in fact, frame 11, and let's just print E. I bet you if I look here very carefully for configuration, what's interesting, the configuration pointer is pointing. That does not look like a null pointer. So TDB Emacs sometimes does some weird things. I'm not entirely sure why. But that actually looks quite healthy. As you can see here, it's really quite nicely populated. All the configuration points are here, are available. So not sure why that's failing, but let's just follow the frames. So frame 10 again, I guess. I don't think there's any particular problem with this. Let's make sure we didn't do anything silly with the feature group. Looks alright. This is really where everyone's going to tell me I should be using Rust, but there you go. Then let's print FG, I guess. Yeah, FG doesn't look very healthy actually. looks very unhealthy. So I wonder, well, in these kind of cases, one thing is always useful to do is to say, first let's just quit on GDB. And one thing that's always very useful to do is to stop using references for a minute. Because it's just, it could just be that you've missed the logic, you miss some very obvious thing in the logic, and these are very, very simple types anyway. You can copy them across. I don't know why, I can't see anything wrong with it, but okay, so that's clearly not what's causing the problem. But I mean, you can imagine there's nothing particularly wrong with our feature group, I don't think. It's as if you can't find the feature. I wonder if we are so early that the feature has some variability transform that's not yet executed. But I think that's all happens as part of the bootstrapping process actually. So all of this stuff, there is like a bootstrapping transform, bootstrapping chain even. It has actually job with a physical model if I'm right, if I remember rightly. And to be fair, I think we might have to. So we're already half past. So okay, right. So let's just do a quick recap of this. I think we're going to have to end up doing this on the background. But this is some very, very silly problem. Nothing particularly clever going on here. So all that's happening at the moment is we don't seem to be able to get the features, and when we try to query for those features and try to read them off the configuration, it all bombs out. This is probably just something very trivial, some reference that we're not passing correctly somewhere, or some dereferencing we shouldn't be doing. But it's a bit difficult to debug these things while talking, so I'm going to go back. I'm going to go offline for this. Nonetheless, what we're trying to achieve, just to summarize what we've done, is we're trying to just basically move a couple of types from here, these two guys here. We're going to move them to their proper location, kind of proper in quotes, because it's not really their end destination, but for this refactor, into the logical model, and then we're just going to create a transform that does the processing, the reading of the configuration for those types, and the populating of the model. And then finally, oh, and of course we're going to have to merge that into the merged model, so that's easy enough. And while all of that's done, then all we need to do is then to query somehow the logical model by ID, and then that will return us the streaming properties, and so the assistant will more or less remain as it is. Okay, so we'll just stop this video now. I'll do some work on the background to try to understand what's going on, and then we'll resume once we are in a happier place, I think. Okay, thanks for watching.